All right, so we're back. We're back lead coding. We're back lead coding. We're gonna do another question to make up for missing yesterday. I was. Can you imagine? I spent all day yesterday trying to debug some Puppet code. In case you know what Puppet is, it's a It's an infrastructure. Infrastructure thingamabob that allows you to configure servers via code. Infrastructure as code, and the fucking missed a comma, and the error, right? The error was like fucking buried in one of the servers, which I couldn't access because if it doesn't build the server, I can't see the error. So I spent hours trying to fucking figure out what the problem was. Literally had to just keep running until I saw a comma was missing, and it fucking worked. Literally spent days on it. Days. Whatever, fuck it. We're back on LeetCode doing questions we've already solved about a month ago, but I rushed, so I want to like go back over the concepts. We got auto draw open. Auto draw is a pretty good program for drawing, I guess. Anyway, cool. So we're just gonna do it again. Not look and pick a problem. We are still gonna do array questions for probably a few more days, and then we're gonna move on to what else? I don't know. Maybe the thing is, I'm pretty shit. I'm pretty shit at recursion and tree, so I might tackle easy tree and or try or whatever. Try and theme questions. Maybe hit some heap. I don't know. We'll see. We'll see. Anyway, let's just randomly pick. Don't want to look. Blah blah blah. What do we land? Oops. Okay. What are we landing? Okay. What are we landing on? What are we landing on? And boom, contains duplicate. All right. Let's do this. I don't want to look at the solution. So let me make sure I delete everything. All right. Okay, contains duplicate. Given an array of integers, find if the array contains any duplicates. Okay, simple enough. This is kind of a thing I kind of already do in work anyway in terms of algorithms. Why the fuck does this have this many dislikes? It's such a this is one of the most common things you have to do even in the workplace. Like this is literally an algorithm you'll have to use at one point in your work career. That's not one of those bullshit like inverted binary tree questions. All right, cool. This is a pretty simple question. Yeah, you have your array nums, and you make a set, and a set in Python, of course, is a data structure that has unique elements in it. So basically the mathematical set. Anyway, so yeah, simple. We just for num in nums, if num, well, what are we actually returning here? Given an array of integers, find if the array can, just find if it contains any duplicates. Okay, so you don't have to return anything. So this could be done in on time, on space, essentially. Well, no, because we're making a scene thing over here. Anyway, for num in nums, if num in scene, return false. Else we just want to add scene, the number to scene. And then if it manages to for loop your whole thing without being seen, then you can just return true. Fucking wait, what? Oh, sorry. Yeah, we want to add it every single time. Of course. What? For num in nums, if num in scene, well, actually, we should probably add it first. Scene dot. Actually, no, that's stupid because we want to, of course, add one, right? Yeah, so we check is one in scene, return false. Oh, sorry, we're seeing if there's a duplicate. Yeah, sorry, it's the other way around. Okay, cool. Yeah. And this should be false. And let's just test the empty array. And let's test one element. All right, looks good to me. All right, decent solution. Um, I'm sure there is some bit operation shit you could do here with like the XOR operator. I can imagine maybe carrying something over and talking about like maybe like I don't know. You're saying, if, for example, you have the array 1, 2, 3, 1, right? I can imagine a solution. I don't know, because like I know like there's binary operation questions, but what is the chances you get asked a binary operation question unless you're like applying for like a hardware position or something like that, or really just you're I don't know you're fucking coding it in assembly or something, or I don't know. See, I don't know, but I'm trying to think actually a bit operation. So if we stored one in a bit, right? If we said I don't know, we called it current, and it was the basically the XOR between 0. So XOR means basically return 1 if there's a difference, or is it return 0 if there's a difference? Let me check. I kind of forget. XOR logic table. So it's one of those. The XOR operator is yeah, here we go. All right, so if there, oh yes, that's right. If there is a difference, return true. If they're the same, then return false. All right, so yeah, so actually, I can imagine a XOR solution here. Okay, if we start the operation at 0 and then compare it XOR it to 1, there is a difference here. So the result over here in index 0, current becomes what was that again? If there's a difference, return 0, or was either I forget. If there's a difference, return 0. Okay, if there's a difference, return 0. There is a difference. So it's because there's a difference, then we have 0, right? And then let's say we go to 2, and now we carry that over, and then we say 0 XOR, the binary of 2. The point is that is there a difference, Don't even need to bother to write the binary of 2, because the point is there a difference between that and the current thing? There is a difference. Boom. There is a difference. Boom. Now, here's the thing. There is no difference, right? So the result should be... Well, I mean, I was kind of hoping it would be something like that at the end, and then it would return 1, right? Wait, hang on. Oh, sorry, that's the NOR gate. Whoops. Oh, I was looking on the wrong fucking gate. Okay, so if there is a difference, then return 1. Wait, was on the same shit? Alright, so basically, if there's no difference, return 0. If there is a difference, so if there's a difference, return false. That's the point. That's the point. If there's a difference, return false. Actually, no, I'm interested. I feel like there is a bit operation solution to this. You have the array 1, 2, 3, 1, right? If you have this as an array, I'm interested. Is there a bit operation solution to this? I feel like there is. Okay, so you have this array here, 0, 1, 2, 3, right? And you could ask yourself, if we start, if current, let's say, starts at 0, and then the next operator equals, I don't know what to call it, I'll just call it x equals current XOR, let's say current plus equals XOR 1, the binary of 1, right? Because that's what happens when you XOR this. So it would be, it would be 0, 0, 0, 1. What we're asking here is there a difference between 0 and 1, the binary 0 and 1, right? There is a difference, and I literally must have short-term memory, because why can I remember? If there's a difference, return 1. Okay. If there's a difference, return false, essentially. So because there's a difference here, right? the result here becomes false, but which means essentially it is 1, right? So we have 1, and then we are on 2. So let's say we did 1 XOR. So 0, 0, 0, 1 XOR against 0, 0, 1, 0. Really all we're asking ourselves here is, well, actually, if we write out the full binary here, we'll see that we have, oh my God, we'd see we have 0, 0, 1. The point is there a difference? Do I actually have short-term memory? Why do I keep forgetting what XOR does? If there's if there's no difference, okay, cool. If there is no difference for 0, there's a difference. All right, so the result here is 0, 0, 1, 0, right? If we then XORed it with 3, we get 0, 0, 1, 0. 3 in binary is 1, 1. If there's a difference, return 1. There's no difference. So now we have, so if you can imagine, right, the XOR operator cancels out, the XOR operator cancels out, imagine like at each time we loop through this, right, the XOR kind of accumulates any differences. As you can look at before, right, we had, see how this result is 2, and see how we went from 1, 2, 3. Notice how things kind of cancel each other out. So let me explain, right? So now we're here at 1, and now we're comparing 1 and 1. And because we're comparing 1 and 1, the result then becomes, oh, wait. Yeah, the result becomes 0. Wait, am I even thinking about this right? I don't even know if this is a thing. Like, is this a hash? I'm trying to think. Like, can you? No, I feel like there is a bit operator. I feel like I can use an XOR operator here to solve this. Does this make sense? Hang on. I remember doing something similar to this once with XORs. I can't remember though. Am I thinking about this right? Let me give it a look. Let me see. What was my previous solution? Did I use this simple? I mean, or rather, is someone here using bit operator? Let me see. Bit. Let's type bit. Bit manipulation. There we go. Ah, yeah. See, that's kind of what I was thinking here. We carry it over. Yeah, that makes sense. That makes sense. Is there a way to make Java a bit tighter? Oh, there we go. Bit manipulation. This guy kind of does it a long way. Did I solve this with a bit operator, or did I use the set? I don't remember. Oh, I used the set. Yeah, I didn't use the bit operator. But yeah, it definitely feels like this could be solved with a bit operation. Now, hang on. I want to think about this. This is an interesting interesting way to kind of tackle the problem. I'm interested. So if we start at 1, right? Okay, like I said, we start current at 0. We start current at 0, which in binary is 0, 0, 0, 0, right? And because obviously 4 bits is all we need to represent these numbers. We then have 2, right? So if we XORed against 2, all right, if we XORed against 1, if we XOR against 1, right? The result of that becomes, I swear to God, I keep forgetting what XOR does. XOR, oh my God, XOR is if there is a difference. If there is a difference, return 1. Okay. If there's a difference, return 1. So there's no difference. So as you can see, we XORed 0 against 1, we get 1, right? At this point of the loop. We then go over here and ask ourselves a question. 0, 0, 0, 1 against 0, 0, 1, 0, the binary of 2. There is a difference here, turn 1. There is a difference, return 1. Boom, boom, boom. So now we have 3, right? Boom. Boosh, ba 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 boom. Ba ba booey. Is that some kind of TikTok thing? I don't know. But then now look at this. Right? Look at this interesting thing. We now have 0, 0, 1, 0. That's 3 in binary, right? Wait, am I 2 to the power of 0 is 1, 2 to the power of 1 is 1, plus 2. Okay, yeah. And 3 in binary is 1, 1. Now, like, yet again, there has to be a difference. No difference, no difference, no difference, no difference. Now, this is the interesting thing. Notice how the XOR accumulates values based if there's a difference and will subtract from what's been accumulated if it's seen it before, right? Notice how we accumulated 1, we accumulated 2 because they're different. Now we have them stored in binary as 0, 0, 1, 1. But now because 3, right, is not different from 1 and 2 combined, it should take it away and make it 0, right? So now that we have 1, we have 0, 0, 0, 1, right? And because we have now the result would be 1, this answer would return true, which means there's a duplicate because we have 1, right? 1 gets stored in this like magic accumulated, store, right? 2 gets stored in it. Now we have 3 stored in it. 3 eliminates these 2 because it's kind of like, that's how I like to imagine XOR working. I don't know if there's a technical thing or not, but like basically 3 eliminates the 1 and the 2. And because now we have 1 left over, right? If we had another 1 here, if there was another 1 in here. Oh, that's actually interesting. If there was another 1 in here, actually, what would happen? Let's see. We'd have 0, 0, 0, 1. Oh, yes. Yes, yes, yes. That is interesting. Actually, no, it wouldn't matter because at this point it would have returned true anyway. So it doesn't matter if there's extra 1s. It just returns on the yeah. Okay, you know what? I think that's a solution. Let's try a bit manipulation solution here. Current equals 0. Current equals 0 for I. No, I don't even need the for I. For n, for num in nums. Yeah, we should be able to literally just do this. Current plus equals, or rather, current XOR equals for num in nums. Current. Yeah, so then essentially we ask ourselves if current equals. Hang on, I need to go take a shit. I'm not stopping the recording. All right. Sometimes you just gotta take a shit, you know what I mean? And I told you, I'm not editing these videos. I'm just not editing these videos. So, if you're the unlucky person to watch this, just skip. I don't know. Just hopefully you skipped. What was I doing? All right, bit operations. What carrying over? So what if current, i.e., if it's if not current, then return true, else return false. So I don't know. To me, that kind of makes sense. To me, that just kind of makes sense. Let's see. Oops. By the way, when I say if not current, that really means, so in Python, when you say if something, there's like data, every data type has like a default true and false, right? Like a base type true and false. So if you're saying if current, what you're doing is saying, ooh, I thought that was gonna work. It's returning true if, wait, what do you mean? Wait, what? Wait. Why does it return true for 0? Let's look at our logic again. If we had just 0 in the array, and we have current and current, so we're comparing 0, which is current, and comparing 0, we end up with 0 because there's no difference. But I'm saying if not current, i.e., I'm saying, so if you said if current, you're saying if current equals 0. But I'm saying, all right, you know what? I'll be more explicit. I'll say if current equals 1. All right, this should fix it. Oh, it doesn't. It fucks it up for 1. I won't lie. I'm very interested in this bit operation solution. So if I go back to say if not current, and then if I had a case where if actually no, why would this return true? I don't understand. If we had 0 at the beginning, right? If we had 0 at the beginning, that's just 0 compared, and we OR it against 0. The result is 0. But I'm saying if not current, i.e., if 1, return true. Else it should just return false. All right, I'll be explicit here. I'll say if current equals 1, right? It will then fail on this case 1. It will fail on 1 because it will fail on 1. So if we had 0, 0, 0, 1 compared to the current, the result then becomes 1, right? The result is 1. So, yeah, it returns true. That guy expected to. No? Hang on. I'm genuinely interested. Let me see if anyone has done a bit operation solution here. That would be in the discuss page. Discuss bit operation. Bit Python. Python. Okay, let's see. Has anyone used a bit operation here? I feel like that's like, if at this point, if your code's this long, what's the point of even using the bit operation? Let me see. Nope, that's not bit operation. So why is it coming up as a searching thing? Let's see how to create a bitmap to solve this. Blah blah blah. Bit operation. Okay. Blah blah blah. Single line fast. Nah. Wait, this dude goes, if the length... Oh, that's pretty good. It's pretty good. If the length of the thing is not equal to the thing. Well, it's pretty good. Because obviously we don't care about the actual item. We just care that, it's true or false. Pretty good one-liner. Usually one-liners are trash. I don't know. I must be just tripping because I really thought there was a bit up. Hang on. Bit manipulation contains duplicate Python. Determine if all the characters use an extra to determine if there are duplicates in. There we go. This is what I'm looking for. Yeah, okay. So for X in duplicates, if XX print true. Is that not what I'm fucking doing? What? Naughty. Should not be using two for loops for cutting duplicate. You're making the thing too slow. Is there like a really simple bit operation here? All right, let's see. Well, let's use list of items as bit indices. I don't know. I felt like there was find duplicates of an array using bit array. Blah 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 blah. Python 3. Let's see. That's just wrong. I'm not making code that long for something so simple. Find non-duplicated integer. I guess I know. I'm sure there's a way to do it, but I don't care anymore. Let's go solve another problem. Easy. Status solved. We're looking for array questions only. All right, so I'm gonna just now look. Blah 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 blah. Boom. Find number with even number of digits. I'm not gonna look at the solution. Let me quickly delete it. Oh, good. All right, cool. Cool. Okay, it seems like I liked this before, so I must have liked this question. Then it's a pretty recent question. 1,295. I think that the latest is in the 1600s. Given an array of integers, return how many of them contain an even number of digits. Return how many contain an even number. Only. Oh, okay. Yeah. Okay. So. Yeah. Let's draw something out. I'm really deeping if I should get an iPad to make these things, just so I can draw like it's paper and save the notes better. Cause I feel like that would just be better. And plus, iPads are pretty cheap. The funny thing is, iPads have the same features as iPhones. They're just bigger. So I'm assuming they charge more for the iPhone because it's more popular. So that way, obviously, you make greater return on investment. You know how it is. And plus, iPads usually get like the cool features first. Like they got Touch ID back on the iPads. And does that have Face ID? Do iPads have Face ID? I don't even know. iPad Air. I was watching the thing recently. Like the iPad Air seems to be better than the iPad Pro. I'm confused. Like, okay, hang on. Apple UK. I'm kind of confused if, but I won't lie. I feel like I should get an iPad to make these things. Save on my notes and whatever. Because I have all these notepads and stuff, but it's like I just keep running through them and I'm not looking back at shit. So then it's just scrap away paper. I feel like I could review better things. Plus, I could like obviously view the notes on my phone and my MacBook. iPad Air, iPad Pro. Is there like a comparison thing here? Let me click buy. Is there like a comparison thing here? All right, let's look at the 12.5 inch space gray. 120 gigabytes should be good enough. Should it? Or should I get the bigger size? Yeah, fuck it. It's only £100 more. Wi-Fi. I'm not engraving Uzumaki on it, but I want to know. Like, I want to compare. Like, what is this doing compared to the new iPad Air? I feel like the iPad Air is looking better. I'm confused. Is there like a compare iPads thingamabob here? Just give me the specs, like list side by side. There we go. iPad Air 4th generation. This is the new one, isn't it? iPad Air 4th generation. Okay. Yeah, these are the new ones, I think. Yeah. Yeah, okay, let's see. Like, what's the difference between them? Oh, this got a better camera. I don't give a fuck if my iPad has a fucking three array camera, because what the fuck am I doing with that? I have a phone for that shit. Like, who's taking pictures with their iPads? Genuinely, who is taking pictures with their iPads? Anyway, all right, here we go. So, promotion technology. See, motherfuckers add promotion to iPad and the finger. But which, yeah, like, what the fuck? Add that to the fucking. Like, you already have USB-C as well. Add it to the fucking iPhone, you fucking dickheads. I always find it funny when they make these comparisons. Up to 10 hours surfing on the web. Like, wow, okay, that's just such a shit statistic to compare of how long. I don't know, in my opinion. Yeah, I don't care about the camera stuff. I'm interested. Why would you get the Pro? Is what I'm trying to think about here. Other than the camera, what is and obviously the size. What else is there a reason? Video record. I don't care about that. That's why I have a phone. I don't care about the phone camera, audio. Let's see, 2-speaker, 4-speaker setup, secure authentication. Oh, so the Pro has Face ID, and these got Touch ID. But I won't even lie, to be honest. I wish things had both. Because sometimes I need Face ID, especially with this mask bullshit and Touch ID, you know. And yeah, in terms of network stuff, it's the same. So pretty much, there's only two reasons that you would get this: the size and Face ID. Is literally the only reason you would spend like £400 and, well, £410 more. Well, sorry, £390 more is literally the only reason you would get that. But it's like, what's the size of these iPads? Like 12.9 inches is big, I guess. But yet again, it's like I have a TV to watch stuff, so I mean, I'd be using this as a notepad, to be honest. 64 gigabyte. 64 gigabyte. I mean, I wouldn't imagine myself taking pictures and videos, so I think 64 would be enough. Wi-Fi is good. I mean, why would I'm not gonna buy a SIM card for my thing. You know, you'd add an engraving. It'd be the God Uzumaki. Save that bitch. Oh, okay, yeah, they got the whole thing here. Oh, Touch ID is pretty good. Apple Pencil, 500. I won't lie, that's a pretty good deal. That's a pretty good deal, in my opinion. £500. I'll add that to the basket. I don't know. And then, you know, we get the Apple Pencil. Definitely would get one of those. £120 for a fucking stylus, but, you know, fuck it. You know, the game's the game. The God. You know, the typical the God. The God Uzumaki. Save. At the basket. Review bag. You know, I think £698. That's pretty decent. That's not that expensive. Like, I thought iPads would cost more. Interesting. I don't know. I'll definitely think about it. I don't want to just buy it because it's something new. I want to know, am I really going to be taking notes on it? But anyway, back to the thing. Find numbers with even number of digits. So we're given an example here. Okay, so we're given this as an example. All right, we have this as an example. We're still recording? We're still recording. Cool. So we have this as an example, 1200. So we want to find so we're not looking for even numbers. in even integers. That would be way too fucking easy. We're looking for digits that have an actual even number of digits in them, as in 1 2 has one value, two values, 1 1. It's even. Odd, 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 even. Right? So yeah, the answer is 2. Yeah, so cool. So this would be a situation of let's think about it, right? Let's think about it. What makes all right, so cool. Cool. I kind of have an idea here. So we have 1 and 2. 1 and 2. I mean, if you had 12, right, and you moduloed it by 10, well, actually, if we divided it by 10, first of all, right, if we just normally divided it by 10, so let me go back. If we just normally divided this by 10, then the result, we get 2. Sorry, let's say 2. We get 1. And if we modulate it by 10, the result is 2. And then, these are two values separately, and the answer is even. But in the event that we have 7, 8, 9, 6, a digit that has 4 digits in it, then what are we doing here? We could do two things, I think. We could, if we modulate it by let's say we divided this by 10 continuously every time of the iteration, right? Yeah. What do we get here? We get the problem is it will give you the result. Well, obviously the answer would be 789.6, but that's not really what I'm looking for here. Well, actually no. Okay, the first. Okay, I'm trying to think here. Maybe we should modulo plus modulo equals it each time. That way we do, and let's say every time we do that we count, right? So we first would be 6, and then, but it just returns the remainder though. It doesn't return the whole thing. It'd be 6, because that's the remainder. Well, the idea is that we'd have 6, 9, 8, 7 as we keep modulo through it by 10. Right? Does that make sense? I could say something like count equals 0 for num in nums, and then say something like yeah, pretty much at each iteration we just sorry, did I say for num in nums? For num in nums. Oh yeah, that's right. Yeah. At each iteration, this might be an O(n) squared situation actually. Hang on. And then for n in num, n. Hang on. I'm interested just to see what this outputs. Output equals the array for n in num. For n in num, we could do something like. Okay, so hang on a second. 7,896 divided by 10 is 789.6, right? But the result, oh yeah, that's right. The result would be floored, so it would be this. Wait, couldn't we just then divide it each time we pass? And just how many divisions is how many times we count? But then it's like, isn't that just the amount of passes you could do? Or, oh, I see. Every time you divide, you ask yourself. No, because we want the remainder, right? The remainder, we want 6, 9, 8, 7. And let's say we stored the remainder each time in like a thing, right? No? Hang on for a second. Current equals this. For n in num, n with this, well, I can't really do that. Oh, wait a minute. why are we even doing maths on it? We could literally just convert it to a string, right? We could, yeah, shit. We could literally just do for n in string. Sorry, for num in nums, right? If string num, and if the length of that, if the, okay, we're trying to count, so count equals 0. If the length of the string of num is is even, right? Is even, then count plus equals 1, and then just return count. This is a on01 solution, on being time, o1 being space. Invalid syntax because I said return count. So yeah, this should work, because converting an integer to a string is an O1 operation. I answered this on the 28th of thing. Yeah, that works. Cool. But I feel there is a mathematical. So here's the thing, right? Don't just submit a solution. Try to optimize it, I feel like there definitely is a mathematical solution to this. Kind of the first thing I was thinking about here. Because if we look at it, every time we go through a number, right? But I feel like the mathematical solution would be O(n) squared, because we would have to we would have to go through one by one, right? Would be the one loop, but then we'd have to go through 12, right? No, am I wrong? Let's say n equals 12, and I said count. Count equals 0 at the start or whatever, and then we said something like n modulus 10, right? N modulus 10 would get you 2, and if you modulo it again, you'd get 1. Those two together in that second for loop would be one count, right? Because if you go with the 3, 4, 5, for example, if you modulo this with 10, you get 5, right? And then you modulate it again, you get 4, you modulate it again, you get 3. And this would be the count of 3 in the second for loop. So this solution, I feel like, would be O(n) squared. So actually, it doesn't seem to be the most optimal to me. But the thing is, I always kind of forget how modulus works. So I'm going to open PyCharm really quick. Because, yes, I don't work with modulus every day. So I kind of forget how things work sometimes. Let me switch the output to PyCharm real quick. PyCharm. Okay. All right. Switching the output to PyCharm real quick. All right. Oh yeah. Sometimes I like to solve people's problems on Stack Overflow, but fucking motherfuckers are fast, bro. Like, motherfuckers are fast. They just be like out here, solving these shit, fucking speed of light. Like, chill out, man. Give me a chance here. Like, the fuck, you know what I mean? All right. Anyway. All right. So let's quickly hit up PyCharm. I just want to check something really quick. If we're given the value, num equals 7, 8, 9, 6, or whatever, and you said for oh, wait a minute. Yeah, for I in range, the length of num, right? The length of the string of num, then we could say something. Oh, sorry, it's two ranges here for some reason. For I in the rend, so basically we're going to do this 4 times, right? If we have a count. A count here equals 0. And then we said num, right? Num. What doesn't make any sense? Because I still have to convert it to a string. Actually, no. Yeah, we can just do this. If for num, we're going to the string. So for num modulus, the int of I, right? Hang on, I'm just gonna. I just want to see there's a store, you know, num modulus int of I. So, you know, R for remainder. And store dot append R. I just want to see what that outputs really quickly. Integer division or modulo by 0. By 0. Oh, because this is an index, isn't it? It needs to be +1. Oh, need to print store. What? 0000? What the fuck's going on here? Actually, no, I don't. Why would I convert it to a string? Well, for I in range length of the string of num. Hang on, I'm just gonna print I. Actually, no, yeah, 4. 4 is, it gives me 4. The remainder, when I'm saying, unless I am, oh yeah, sorry, this should be num I. Well, the string, the string of num I, that should be string of num. The string of num I, string of num I. That does not. That just feels wrong to me. That's gonna fail, isn't it? Yes, that doesn't make any sense. Sorry, the string of num. Wait, what? The string of num I. Wait, what? The string of num. The string. Okay, hang on. String num equals string. Sorry, equals the string of num. And then we take that. Oops. Take that. Put that there. Take that. Put that there. So we have string num, right? So now it's a string. It's a string. I. Right? I. +1. So we have, what the fuck? 114. What the fuck's going on here? Am I mistaken? 114. That should be 6987. 114? What? The int of, if I printed, I'm a print string num. No, yeah, sorry. Why do we have 1 here? Invalid syntax. Why? Invalid syntax. Okay. Wait, what? Johnny wouldn't give it to me. I give it to you. Okay, so that's right. Oh, wait, what the fuck is num? Why am I saying num? Num divide. Oh, wait, shit. Sorry. Yeah, wait. Yeah. It should be not num. Well, yeah, sorry. It should be, 7896 modulo. Sorry, this should be 10. Modulo 10 each time. So this should be plus. Well, yeah. No. Okay, hang on. Let me just run it. Oh, yeah, of course it's 6666. I'm not updating this remainder. The remainder, okay, so the remainder here is the number 796, right? But The remainder is num equals. Wait. The remainder is num modulus 10, but it just does that each time. What needs to happen is that num needs to be updated, right? Num needs to become, yeah, num modulus 10 needs to occur. So num, so essentially this has to happen, right? And if we run that, well, actually, if we, let me print num each time just to make sure. Let me get rid of that. Okay. Oh, wait. What? Shit. Each time I just printed the end. It's not updating for some reason. What do you mean? N equals... No, so num equals... Right? Num equals... Num modulus 10, right? So... Yeah, at each point, num should be the next remainder. But it's just giving me 6. Oh, that's because the result is the remainder. So what if I use div mod? Div, how does div mod work again? Div mod, division modulus. How does this work again? Div mod takes in two values, a non-complex number and a non-complex number, the numerator and the denominator. But what is it outputting though? It's outputting the quotient. All right, so it outputs the quotient and the remainder. And we want the quotient. So what's its usage? It is a div mod. Oops, where's Python? PyCharm. So num equals div. Well, actually, it's a two-value thing. So its output is Q and R, right? Equals div mod of num and 10. And if I printed Q and OR, so we got 7, 8, 9, 6, which is correct. It's what I want, but it's not updating it though. Why is it not updating it? Oh, I see. Because num would have to equal Q. And then we do the process again, right? So 7, 8, 9. We got 6, 9, 8, 7. Oh, okay. This could work. And then we say... So then... yeah, so now we can update count. Count equals the length of the store. So, well, actually, no, that's what we would return. We'd return the length of the store. So we'd print length of the store, and we get a syntax error. What the fuck is? Oh, where the fuck did this come from? We get a yeah. Result is in force. If sorry, I'm not even looking. Shouldn't have even shown you the output. Yeah. As you can see, we have the quotient. We got the remainder, quotient, remainder, quotient, remainder, quotient, remainder. And as a result, we get 4. However, you can see the problem here, right? How it would be an ON squared operation, because we'd have to, well, actually, why am I even doing this? Don't even need to do that. Get rid of that. All right. But as you can see how this would be a problem. So if we actually copy this code to leetcode really quick. Let me exit PyCharm. So if we copy this code to leetcode really quick, and we do something, we modify it obviously. So we have our store, I don't know why I'm calling it store. I just for some reason calling it store. We got a count, right? We got the string representation, of the thing. I'm wondering actually if converting a string is an ON or O1 operation. I'll look into that, but I'll just assume it's O1 for now. I mean, it would be O1, right? It's well, actually, I don't know. I don't know the implementation. I'll check later. But anyway, as you can see, what the problem would be, right? If we delete our old solution here, and you could see how we'd have to for loop a second time through it, right? So we'd go count store string num for num in nums for I in sorry for this should be for I in num, and then for string num, which is actually this should be here. This should be here. And then if at the end we just returned, well, actually, if we print the store, if we printed the store, first of all, we get the fuck? Huh? It's adding the things to the, oh yeah, shit, that's right. It needs to have like a current store, essentially. And what we're appending here is the R gets appended to current store, and then we append that to the store, right? What are we on? 1 hour 4. 1 hour 4. Oops, sorry. Then we should have. Yeah, okay. So we got 2, 1, 3, 4, 5. So as you can see, how that would be the solution, right? It essentially then you'd have to go and for loop through it, essentially. So now you'd have the ultimate count, right? And you would say for count. Sorry, for what would I call it? For Q, for the for R, the remainders in store, you'd essentially just say if the length of R is even, right? If it's even, then you return. Sorry, you don't return. Sure, you update the count. So ultimately, you return the count, right? And then it should give you 2. So as you can see, if you submit it to see if I'm just chatting bullshit or not. Yeah, so as you can see, that is a solution as well. As you can see, that is a solution as well. It's not the most optimal solution. This would because as you can see, we for loop through it once, but then we have to for loop through it again, right? Which makes it ON squared. But I'm interested if anyone's used div mod in an ON scenario. Doesn't seem so. So because of that, I will submit this just for fun, a div mod non-optimized solution. I'll paste this in here if anyone wants to check it out. Just to kind of show you there's other ways to do things, really, to be honest. Just for fun, a div mod non-optimized, optimized solution. Python on squared on squared time on space. Of course, the easiest way and most efficient is to use a set, but a set. I just thought I just wanted to use div mod for fun. Aoi, aoi, ano sora, Of course, what's going on here? It's not making it bold. Bold. Of course, the easiest way and most efficient is to use a set. I just wanted to use div mod for fun. I'll post this. Just, of course, the easiest way and most efficient way and most efficient is to use a set. I just wanted to use div mod for fun. Oh, so I guess I should probably add comments for anyone who sees this. So this would be an array of arrays where each index stores the array of remainders of num. For I in range with the num, div q num equals q. So essentially what I'm doing here, just to explain to people in case people want to kind of just look at, just other ways to do things. We can do for I in range, length of string num, where the quotient is we update num to be everything but the remainder, i.e. q. Store the remainder in a current array just for the current number. Then add the current number remainders to the global array. Okay, let's see. Wait, what? Hashtag? Oh, hashtag. Just let me see if this is readable for the crowd. An array of arrays where each index stores the array of remainders of num for da-da-da. Okay, maybe I should put this here. We update num to be everything but the remainder, i.e. q. Da-da-da. Then we use q. Store the remainder in a current array just for the current number. Then add the current number remainders to the global array. And then, then check the length of every array in the global array and update count if it's even. Okay, so an array of arrays where each index stores the array of remainders of num for num and nums. For I in range, we update num to be everything but the remainder. Qr equals div mod. Store the remainder in a current array just for the current number. Then add the current number remainders to the global array. Then check the length. Then check the length of every array in the global array and update count if it's even. Yeah, looks good to me. Just for fun, a div mod non-optimized solution, Python on square time, on space. Just for fun, a div mod non-optimized solution. Let me tag this actually. Div mod Python. Div mod Python 3. Of course, the easiest way and most efficient is to use a set. I just wanted to use div mod for fun. Yeah, I don't think anyone else has used a div mod solution here other than me. Yeah, I think so. Oops, div mod. Yeah, I'm pretty much the only guy who's used a div mod solution here. Of course, the easiest and most efficient way is to use a set. I just wanted, oops, spelled wanted wrong. I just wanted to use div mod for fun. An array of arrays where each index stores the array of remainders of num for num and nums store. Okay, so for I, so actually, let me check. Is string in Python? Okay, string Python time complexity. Or actually string conversion time complexity Python. I'm interested what the complexity in that is. And what is the complexity? Oh, there we go. Without looking at docs, probably 01. Time complexity is all about how much slower a function gets as n increases, and is usually something like the length of a list, or maybe the size of numbers. I bet that the time to convert an integer to a string is probably more or less exactly the same regardless of how big the integer is. Well, I mean, I guess, to be honest, we have the indexes. I don't think it has to be done in like I guess so. I guess time complexity to change. I mean, I could just check myself by going to the C Python code, to be honest with you. Let me just do that. C Python string conversion. I don't even know where to look for this code. Like how to convert a Python string. I don't know. I'm assuming. I think it's 01. I'm pretty sure it is. I mean, it kind of makes sense. Just kind of update each. Actually, you know, it's good to know these things. C Python. Is there like a? Oh, here we go. C Python. Let's check it out. I need something that's searchable, to be honest. Developer guide. There we go. String. Is there anything here on string? These things always have shit searchable indexes. Your guide to C Python source code. Real Python. What the fuck is JPython? Is this Python based on Java? JPython is a Java implementation of Python that combines expressive power with clarity. I did not know this was a thing. Why would you use Java to make Python? I thought like mscripted Java programmers can add the JPython library in their system to allow users to write simple or complicated scripts that add functionality to the application. But you can what? Interactive experimentation. JPython provides an interactive interpreter that can be used to interact with Java packages. Ooh, this allows programmers to experiment and debug any Java system using JPython. Oh, I see. So you can use Python to basically do Java stuff. That's interesting. Here's an example of running Python code inside a simple Java application. Okay, so we got our Python interpreter, JPython hello world. This is some Java code. Try Python interpreter. Oh, I see. So it essentially just lets you literally run Python inside of Java. Right? Print. Here's an example of using Java from Python code. Or you can do it the other way around. Pretty good. Pretty cool. Pretty cool. Pretty cool. Did not know that. I did not know that. I did not know that. C Python. Is this the documentation? Documentation. Download is blah blah blah. C Python documentation. Cython. Cython. All right. String. Come on. Come on. Come on. Come on. Give me some. Give me some good. Give me some good. String. String literals. I guess string. To int. Give me something good here. String literals. Easy binding for speed. Early binding for speed. Parallelism. What was that thing I was looking at? It was Quora. Quora. I bet that the time to give an integer string is probably more or less exactly the same regardless of how big it is. If it's not O1, it's close enough to linear to not matter much, and you'd only start getting a difference when you're looking at extremely big numbers. I can't think of, I mean, I guess it could be O1 if you think about it, because, but that doesn't, okay, obviously you have an array, you know all the indexes, you don't have to go through it synchronously, like you don't need to go like, you can just all at the same time, just convert each thing, right? You know, you convert just the number 1 to an integer is all 1, but you're not waiting for the rest. You kind of just update it all at the same time. I think it's all 1. All right, cool. Let's do one more problem. Call it a day. Difficulty easy, status soft. I won't lie, this shit becomes this is a lot more fun when I'm doing it on a camera. I feel like it kind of helps me practice to think better. Because when I'm doing it on my own, like I have the tendency to look up solutions more and not really use my own brain power. Because like I could just Google it. Why am I trying to think? But I kind of like doing this. I think it's a good. This is probably. I think I'm probably the only guy to ever leetcode this way. Nah, it can't be. There's someone who's taught of teaching themselves like this too. I don't know. Anyway, yeah. So we got our. We're still looking at array easy questions. We're gonna look at just a random one. Oh, by the way, the reason yet again I'm doing these is because I've already solved them, but a lot of the principles I've forgotten. And a lot of these questions are some of the best questions you could use to practice these data structure algorithm questions, rather than like picking some obscure, very specific contextual like question. Getting a lot of texts. Okay, I'll look at that later. Anyway, pick a random boosh. Remove element. Like, I don't want to look at any solutions here. All right, cool. This has a lot of dislikes. Don't remember doing it though. What is it? Given an array nums and a value val, remove any instances of that value in place and return the new length. The order of elements can be changed. It doesn't matter what you leave beyond the new length. Clarification. Confused why it returns in it. Oh yeah. Okay, so we're given 3, 2, 2, 3, and the value is 3. What is this? Given in a value, remove all instances. Okay. So your function should return length equals 2. So we just returning the length. Okay. Oh my god. Oh, let me stand up for a second. I've been sitting down for an hour. See, the thing is, right? Sometimes it's just good to get up, chill for a second, eat a banana or something. All right. Cool. All right. Let's get to answering. So you want me to remove all duplicates, essentially. Sorry, not all duplicates, all instances of the value. So yet again, let's write our example. We got this, and the value is to remove is 3. So we have this. We've got 3, 2, 2, and 3, right? So let's think for a second, right? Let's think for a second. We could either go forward or go backwards here, right? Let's start thinking about what's the best to do. If we have 3, if we're a 3, right, and we are 3, which is cool, and we have an if statement, if blah 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 equals the value. In this case, it's 3. What are we doing with this array? What are we doing with this array? We want to essentially remove it, but what we essentially just shift the whole thing, right? You just want to shift literally the whole thing. So we count in shifts. We can count shifts here, right? Oh my days, draw. We can count the shifts, right? Every time we shift, we increase shifts and then return the length. So that way, okay, we have 3, 2, 2, 3. Of course, I don't think this can be done in a for loop because the length of this will change. Well, no, it wouldn't, would it? Well, if we're shifting, so then, okay, then the array becomes 2. So 2 becomes 0, 2 becomes 1, 3 becomes 2, right? But you see the length changes. We should add a 0 at the end as well, just so the length stays the same. But I guess if it's a while loop, we don't need to do that. We don't need to do that operation. So then we have this, right? And then yet again, we are 0, but then we're here. We then, if we have 3 here, okay, that's cool. I mean, we have this over here. Oh, that's a problem. Because if we shifted that there, then it becomes 2, 3, doesn't it? Okay. Can't solve it that way then. But the thing is, the result, yeah, we can't solve it that way. Because the result would be 3 if we shifted that left. So let's go back. Let's go back to the drawing board. Let's go back to the drawing board and start thinking about other ways to solve this. Back to the drawing board. Back to the drawing board. Thinking of other ways to solve this. Baby, what you getting into me? I can't believe you can't even fucking hum songs anymore in fucking YouTube videos. Fucking copyright. Google are a bunch of pussios. Fucking, they let the music people labels fuck him in the ass. Seriously. Anyway, all right. So we got our drawing tool. We can't shift because that results in the values being overwritten. So what can we do? If we were to go backwards, let's see. If we were to go backwards, what do we get? We start from 3. We see it's the value we want. So what could we do here, right? We could convert it to 0, maybe? Convert to 0. I mean, if you were to convert each 3 to 0, and then for loop through it again, I mean, I guess that would be a solution. Let's say you converted this to 0, converted this to 0. You then have this array. You then make a new array where it's 2 and 2, and then there's your result, because then you just have an if statement saying if it's not 0, then add it to the thing. Actually, you'd probably want to make it like minus infinity, just in case 0 is a value you're actually looking for here. But it wants you to do an O1 space, doesn't it? It wants you to edit it in place, so I can't return any extra data. It says here. Obviously, that's the easy solution. You know, if memory was able to be O1, very simple solution. But it wants it to be done in place, so it makes it just a tiny bit more difficult. Just a tiny bit more difficult. Not a lot of times I work with O1 space for things, because we have enough memory these days. We don't have to make everything that optimized. Well, I mean, maybe if it's like you're making up something for a plane or something, maybe you need to do in-place operations to save memory. I don't fucking know. But 3223. To do this in place, so I can imagine some kind of swapping needs to happen. Some kind of okay, so, okay. Let's say we start at 3, right? We start at 3. It's the value we want, right? We have our if statement. It's the value we want to remove, that is. What can we do here? We can't shift it this way. We'll overwrite the 2. Shifting to right doesn't really make sense. What could we do here? What if we shifted it to, what if we shifted everything that's similar so that the array becomes 3322, or it becomes 2233? So what if we did this, right? What if we actually do start at the start and we say, we're at 3, right? Take this and keep moving it to the end. Just keep moving it to the end, right? So say, if the value is what we're looking for, then take it and just move it to the end. So the array becomes 2, 2, 3, 3 in this case. It doesn't even matter where this 3 was. This 3 could be here as well. The point is just keep moving to the end, right? And you then, okay, so we could move this to the end, shift this to the right, to the left. So basically, like a little cycler, little washing machine cycle operation going on here. We move to the end, we shift to the left, right? We can do that. That makes sense to me. I mean, if you look at another example, we have, here's a much longer example. Let's try it with this. Let's try it with a longer example just to make sure we have the intuition down. Just to make sure we got the intuition down. So what is it we're trying to remove? We're trying to remove 2. So we're trying to remove 2. So, okay, we're here. This is what we want. Take it and move it here. Then shift this here, shift this here, shift this here, shift this here, shift this here. So the array becomes 0. Let me type that out. The array then becomes 0, 1, 2, 3, 0, 4, 2, 2, 2, 2. Yep. Also, remember to keep track of the amount of shifts. Keep track of the shifts, because that will allow us to know how far to go into, essentially. Or something like that. Maybe not track of the shifts. Okay, let me keep thinking for a second. All right, so then we are then we get here and we see. Actually, see, I can see. I can kind of see where an issue would occur if we move it here. Actually, no, yeah, that will work because we're shifting it after the check. So we're looking at 2. We move it here to the end. We shift, we shift, we shift, we shift, we shift. So then now we have this array 0, 1, 3, 0, 5, 2, 2, and 2. Right? Jeez. Yeah. So we have this array. And keep in mind we did so then we do this 2 here, and we do the same thing. We move it here. We move it to the end. And the reason we're doing this is because we need to keep track of the amount of shifts, right? So essentially, we now have a shift count of 3. So we know that there's 3 elements now that are the same that we're supposed to remove, and they're at the end. So all I got to do then is return the length of the array minus the shift count, right? 1, 2, 3, 4, 5, 6, 7, 8. So essentially we're returning 8 minus 3, 5. So we go 0, 1, 2, 3, 4, 5. So we only have, well, I guess minus 1. So we only need to literally return that length minus 1. So then we would return this right here. Yeah, so I think the trick is just to keep track of the thing you've moved, right? Store it somewhere temporarily, and then shift, essentially. Okay, that makes sense. So we can do this. So we got our shift. Our shifts equals 0. For I in range, the length of nums. The length of nums. What was my logic? My logic was, if the current element equals the value, we want to essentially say the current value, right? So we need to keep track of things. So the current value, we've got our current value, right? Our current value. So our current value. So to move something to the end would be to we just wait, was I making the end equal that value, or was I appending it? I was making it equal the end value, was I? No, you should probably keep track of the value, but then shift first, because you'd lose the 2 here if I overwrote it. So you should shift. So once you see shift, 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 then okay, wait, hang on. I know I have the intuition. I'm just trying to think about how to do it in code. If you have 2, put it to the end, but let's say we shift it first. So we keep track of this in the temp variable, and then we go shift, 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 then shift, to make this, then make it equal the end. Once we've shifted the whole array, right? Once we've shifted, but hang on, I have the intuition. I'm just trying to think how to do it in code. We shift, 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 shift. So we shift, we shift, we shift, we shift, we shift. But the problem is then what does the end become before I actually assign the end? I mean, if we shift it all and then made the end equals 0, and then we can just make this equal that, right? So we could say nums I, we shift the whole, well, first let's keep track. Current, so tracked num equals nums I, right? And then we can shift the whole thing to the left, which is just saying nums. This might need a second for loop because it would be like for num. Shit, hang on. It might need a second for loop. I'll think if it's all one squared, it's all one squared because we'll have to for loop through this and shift them, right? So we'd have to say for num. This is the tracked number, right? The tracked number. So the current I where this does this, we'd have to say that for num, for j in nums, in range, length, for range I to the length of nums, then nums I minus, j minus 1 equals nums j. So we'd have to start here. So we shift everything to the left, right? And we shift everything to the left, right? We then make the end of nums equals 0. And then, well, no, we append nums I to the end. And then let's just see what the fucking output is. And then we keep track of the shifts. And if we returned shifts, no, sorry, shift is not the right thing to return. Nums.append nums I, we return the length of nums minus the shifts, essentially the shifts. Oh my god, shifts. Output is 2232. 2232. All right, so what's going on here? 3223. 222. So as you can see, we shifted the length of nums minus the shift count. Every time it equals the value, we increase the shift count. Minus the shifts, the length of nums would be 1, 2, 3. So if I were to print the shifts, the shifts is 2, right? So obviously the length of, no, it would be minus 1 here, wouldn't it? Still one too long for some reason. Because in this case, if I return the shifts, hang on, let me look at the longer example. Ba-da-ba-ba-bum, ba-da-ba-bum-bum-bum, ba-da-ba-bum-bum-bum. Okay. Doesn't seem to be doing what I wanted to do. You know, I'm kind of tired. I'm just going to look at the solution. Fuck it. What did I submit before? Oh. if it doesn't equal it. Wait, what? For I range, if num's I does not equal the value, then num's current equals I. Wait. Wait a minute. Wait a minute. What did I do here? What did I do here? I said, if it doesn't equal. But you see what I mean? How I kind of forget some of the things. Hang on. For I in range, if the current element does not equal the value, then the current position. Wait. Oh, wait. I think this was the same idea I was doing. It's just I'm using a pointer here. Oh, yes. Fuck. I get what it's doing. Yeah, shit. I completely just forgot about pointers for a second. Give me an example really quick. Three. Okay, I'll take that really quick. Bang a boom. Oh, bada bing, it be bong. So, of course, a pointer. So we have a pointer that's the current unique shift, right? Not unique shift, non-value shift. So what I mean is, we start at 3. This is our current position. It equals it. Sorry, this is. Wait, what? Hang on. Oh yes, yeah. Wait, the current value. The current value equals the num. Oh shit! So I'm saying here, right? If this is current, then what I said was, nothing happens here because it's not the value we're looking for. So we come here, and then what we're doing is saying that this now equals this. It's kind of it's kind of the shift and shit I was doing. Oh yeah, pretty much kind of what I was doing. So now we make this equals current, and then move current over here, right? So we have now the array becomes 2, 2, 2, 3, right? We're saying that this becomes this. Boom. Kind of a little shifter. And then current is here. We move current again. So current here is 1, 2. So current at this point equals 2. And now we get to this value, and we see shit's just looking wonky. You know what I mean? Well, current's not 2. Current here is 1. Sorry. We come here and look at the bullshit. We see that 1 is over here. We now do 0, 1. Wait, that would have to increase each time, no? If it doesn't equal the value. Oh, sorry. Yeah, I was right the first time. Current is 2, so 0, 1, 2. Then 3, yeah, essentially moves here. Oh, yeah, shit. It was literally what I was trying to do with the shifting. I just should have used a pointer. Yeah, that makes a lot of sense. I had the intuition down. It's just the exact method I was kind of fucking up. But then that becomes 3. And then, of course, all we have to do is return where current is. Current is at position 2, right? So we made 2 shifts. We just returned these 2. Literally exactly what I was doing. So I prefer calling this shift position instead. Shift position. Or, yeah, shift position. Yeah, I'll call it shift position. Shift position. If the value does not equal the current element, right? We want to make that current position in the array equals. Sorry, we want to make the current shift position equal the current element, right? So this is where shit can shift into. Then we can increase the shift position, right? So all we got to do is return the shift position. Shift position, position, position. Shift position. Right? And then we do that. Yeah, honestly, exactly. I had the exact intuition. Literally the exact intuition. It was just a situation of I should have implemented a pointer solution, but I'm not beating myself up over that. I would have gone down a path, kept trying to do that ON squared solution I was trying to play with, and it would have worked because the idea was to move to the end, shift, but I should have, with the pointer, keep track of the shift positions. We see the value that we're looking for, right? Sorry, we see. To myself, we're here, right? Current is, well, shift position is 0 at this point, right? We're basically keeping track of the what do I call it? The non stuff so the things we're not looking for is we were keeping track of. Like, so everything to the left is the values we want to keep. Everything to the right is the values we don't want to keep, and we return the length up to the things of until it reaches the things we don't want to keep, right? So perfect intuition. Essentially what I was trying to do. I just should have taught more simply, I guess. Shift the current shift position, but increase shift. Yeah, makes complete sense to me. I'm not gonna beat myself up over it. Because usually if you can't think of the solution really fast, then what's the point? What's the point of doing it? You won't get that time in the interview. But yeah, the intuition was there. Just then I guess I just have to keep looking at pointer questions. I guess tomorrow we tackle a pointer question to see what we can come up with. But nums shift position equals nums I. Yeah, makes sense. Makes sense. Shift position is 0 here. Then we move here. Shift position 0 at this point. We move this to here. Now we can move this here, right? We can then shift again, right? So now we have 2, 2, 2. Now we're here. Now we're here. Shift position is 0, 1, 2. Now we can make that. So then it becomes 3, 2, 2, 2, 3, and we just return the shift position, which is 0, 1. Well, when we return 1, we return 0, 1, 2. We go up to that length, so 0, 1, 2. All right, makes complete sense. Perfect. Good day, another good day of leetcoding. Talk to you later.